Hello everyone, how are you? I hope you're doing well. This is the second part of solving paper 4 theory extended number 42 February-March 2024. In the first part we solved question 1, 2 and 3. Today we're going to complete with question 4. So let's start. Question 4, in A, they say define the specific heat capacity. In general, we know specific heat capacity, it's the amount of heat energy needed to increase the unit of mass by a unit temperature, or the temperature or the heat energy needed to increase the temperature of 1 kilogram by 1 Celsius degree. Okay, so we can say energy needed to increase the temperature of 1 kilogram by 1 Celsius degree or degree Celsius. Okay, in the marking scheme they say it's energy transferred per unit mass per unit temperature. Okay, so this is the definition. I hope it's clear. In part B, they say a volume of 0.0024 cubic meter. This is the volume, okay, of oil is heated in a pan for 7 minutes. This is the time, okay. The temperature of the oil increased from 20 degrees Celsius to 180, which means that change of temperature is actually 180 minus 20, it is 160 degrees Celsius. They say now that the density of the oil, raw density, it is 910 kilogram per cubic meter. The specific heat capacity is 2000 joule per kilogram Celsius. This is the specific heat capacity. Now they say calculate the mass. We already know that density equals to mass over volume. So if we want the mass is going to be density multiple volume, which is going to be 910 multiple the volume, which is 0.0024. And the answer will be almost 2.2 kilogram. Is going to be 2.2 kilogram. This is the mass. Okay, please pay attention to the unit. Here we use kilogram because in the density it is kilogram per cubic meter. Okay, the second part, they say calculate the energy required to increase the temperature. So we need the heat energy. We know already the formula, E equal mass multiple specific heat capacity multiple the change of temperature. Okay, the mass that we got 2.2 multiple the specific heat capacity, which is 2000 multiple the change of temperature, which is 160. Okay, so I did it already on my calculator and I got almost 7 multiple 10 to the power 5 joules. Always remember to put the units. Okay, I hope it's clear. The next part, they say calculate the power required to supply the energy calculated in B. Okay, so I have the energy, they need the power. We know the formula, power equals to energy over time. Remember that the time here is given 7 minutes, which equals to 7 multiple 60. I must change it to seconds, right? So it's going to be 420 seconds. Okay, so power is going to be 7 multiple 10 to the power 5 over 420. Okay, this is 0. Okay, and it will give me almost 1700 watt. Okay, so this is the question 4. Okay, I hope it's clear. Please feel free to ask any question under the video. The next question 5, they say the table 5.1 shows applications of regions of the electromagnetic spectrum. Complete the second column of the table with the region of electromagnetic spectrum used for each application. Choose from the regions in the list: gamma rays, infrared, microwave, radio waves, and ultraviolet. They say each region may be used once, more than once, or not at all. Okay, so it doesn't matter. It doesn't mean that I have to fill all of them. Maybe yes, maybe no. Okay, so let's start. I hope that you memorize the use of the regions of electromagnetic spectrum. We know already Bluetooth connection. Which one do we use for that? I hope you know we use radio waves. Here we put radio waves. Okay. Optical fiber, we use infrared. Okay. Security marketing, it is ultraviolet. Here LET. Okay. Sterilizing food, it is gamma. Okay, it is gamma rays. And the last one, wireless internet, we use microwaves. Okay, these are or should be memorized by you guys. I hope you do. Now they say state the approximate speed of radio waves in air. The speed of radio waves in air, it's the same speed of visible light. Okay, which we all know it is 3 multiple 10 to the power 8 meter per second. Okay, of course you can write it as 300,000,000. Okay, it's basically the same. You write this or this, it's the same. Okay, and remember, this is the speed of all the waves in the electromagnetic spectrum, all of them: visible light, ultraviolet, infrared, gamma, x-ray, blah blah blah, etc etc. I hope it's clear. Now in the second part, B, they say question or figure 5.1 shows successive crests of a wave after a plane wave has passed through a gap. What do they want? They want, on the figure, draw 3 successive crests before the wave reaches the gap. So they want in this part here. Okay. Remember, this phenomenon is called diffraction. Okay, and since here we have like a perfect diffraction, it means the wavelength should be in the same size as the gap. Okay, almost. Also, we have to pay attention that the wavelength, let's remember, wavelength is the distance between two crests. So this here represents the wavelength. So when you're going to draw, you have to draw 3 lines with the same distance. It's going to be, sorry, I don't have a ruler here, so approximately they should be straight lines. Okay, they should be 3 straight lines parallel to each other, and the distance between each two is approximately the same wavelength as it is here. Also pay attention that here the distance, I have to indicate that it equals to lambda. Okay, in the marking scheme you will get 1 mark for drawing them parallel to the barrier, okay, and 1 mark for the same wavelength as the one after the barrier. Okay, I hope it's clear. Next, they say figure 5.2 shows a much wider gap. Plane wave of the same wavelength as in BI, the previous one, is incident on the gap from the left, from here. It is incident from here, from the left side of the barrier. Okay, so what do they want? They say draw 3 successive crests of wave after the wave has passed through the gap. Remember here, notice that the gap is much wider. Okay, so here let me say that the size of the gap is D. It is bigger than lambda. So here we will not have like a perfect diffraction. So how it's going to be, let me change the color. Okay, I have to draw 3 lines, okay, here. Remember, it must be the same wavelength as before, okay, and they should be curved from that side, like this side should be curved, okay, here it should be curved. So it's going to be a straight line in the middle, like here should be straight, okay, and here at this side, this side, this side here, they should be curved, okay. In the marking scheme, they say that the middle part, like here, the middle part should be a straight line, okay, and parallel to the gap, okay, and the sides should be curved as we did already, okay. I hope it's clear. Let's go to the next question. The next question, I already put it here because I need to draw. Okay, so here I hope it's clear. Let me try if I make it bigger. Yeah, a little bit. So they say here, figure 6.1 shows a full-scale diagram of an object and its image. The object is O here and the image is here, I. Produced by a converging lens. The lens and its position on the principal axis are not shown. The lens, I don't see it, okay? What do they want? They want on the figure, draw. First, they want me to draw a single ray to locate the position of the center of the converging lens. Let's remember that when we want to draw any image from a converging lens, one of the rays I draw is from the top of the object. It will go through the center of the lens and it will go to the tip of the image. So how can I do that? I draw a line from the top here and I take it directly to the tip of the image. This is the ray, which means that here, this point here is the center. Sorry, let me change here. Okay, so this point here is the center of the lens. Okay, so if I want to draw the lens, in the second part they say here, draw a line to represent the position of the lens and label it L. Let me use another color. Is going to be here at this point. This is the image. I try as much as possible to keep it exactly on the point of intercept. Okay, so this is the lens and they say label it L. This is the lens. Okay, I hope it's clear. Now they say determine the focal length of the lens by drawing another ray. By drawing another ray here, they want me to draw. Let's remember, if we want to find the image, I can draw many rays. One of them we just did in blue color. The second one, we know that if the ray comes from the top of the object and it is parallel to the principal axis, it comes to the lens, okay, it's going to go through the principal through the focal point, okay, and it will go to the tip of the image here. I hope it's clear. Okay, so this will be the second ray. Is going to be this, it will be incident here and it will go through the focal point. So this will be the focal point. Okay, and since this diagram is full, as they say, it is full scale, it means I can measure. I use a ruler okay, if you measure it on the paper in front of you, is going to be almost 2.1. You can measure it, is going to be 2.1 centimeter. Okay, pay attention that if you print this exam at home, maybe it's not going to be the same scale as the paper in the final exam. So if you don't find it 2.1, don't worry. Okay, it's something normal. I hope it's clear. In part C, they say that the object is moved 2 centimeters closer to the lens. Okay, it became 2 centimeters closer to the lens. So I'm going to draw now the new position of object. Okay, 2 centimeters closer to the lens. So it's going to be, this is the new object here. What do they say? They say state 2 changes to the characteristics of the image. So I need to draw the image here. Okay, let me use, which color I'm going to use? I need a new color, which is, no, the yellow will not be appropriate. Let me use this color. Okay, let me draw. First of all, from the top of the, no, not this one, sorry, I need a straight line. Give me just 2 seconds, I'm sorry. Okay, okay, from the top of the object and through the center of the lens. Remember, the position of the lens didn't change. Okay, I make it as tall as possible. Okay, this is one ray. Another ray, guys, is going to be from the top of the object towards the lens. Okay, and then it will go through the focal point. It's going to be like this. As you can see, guys, like here to the right side, they are moving away. You see, this is the 2 rays. They are moving away. They are not going to meet anywhere here. So what do we do right now? I have to take the extension of the 2 rays to the left side. I'm going to use another color to show the extension of the 2 rays. Okay, so I'm going to draw from here. Is going to be extended. Try to make it the same straight line. Okay, and as tall as possible. Okay, the other one will go from here almost in the same. Okay, so they met, as you can see, they met right here. So this will be the new image. Sorry, it should be like a straight line. This will be the new image. Anyway, I just care about, of course, here they don't ask me to draw, but I draw just to give 2 characteristics of the image. As you can see, since it is in the same side of the object, remember this is the object and here will be the image, is going to be virtual. Okay, and as you can see, it is bigger than the object, so I say it is enlarged. Right, it is enlarged. I can add another property, which is upright. It's not inverted, it is upright. Okay, I hope it's clear. So this is the answer of this question here of C. So it is virtual and it is upright. Also it is enlarged. So these are questions 4, 5, 6 of this paper. I hope it's clear. Remember, I'm not making I'm not solving all the questions. I need the videos to be short a little bit. Now it's almost like 20 minutes. Anyway, feel free to ask any question under the video and we'll complete later. Okay, have a nice day. Bye bye.